Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 918, the Maximum Sum Circular Subarray challenge. This is a brilliant extension of the classic Kadane's algorithm that tests your ability to think outside the box, or in this case, around the circle. Let us look at the problem statement. Given a circular array nums of length n, our goal is to find the maximum possible sum of a non-empty subarray. A circular array means the end of the array connects back to the beginning. This allows subarrays to wrap around from the last element back to the first. Think of it like a circular jewelry necklace made of different gemstones, some precious and some cracked. You want to cut out the single most valuable continuous segment. One option is to just take a normal piece from the middle. But because it is a circle, you could also cut out the least valuable section, leaving behind a high-value segment that wraps around the clasp. The only rule? You cannot take the same gemstone twice. This leads us to our strategy. The maximum circular sum can only happen in two ways. Case 1, the best subarray is just a normal one in the middle, which we find using standard Kadane's algorithm. Case 2, the best subarray wraps around the edges. To find this, we calculate the total sum of the entire necklace and subtract the minimum subarray sum. By removing the worst possible middle part, we are left with the best possible circular part. Our final answer is simply the maximum of these two cases. Let us dive into the dry run. Look at the screen. We have our input array 5, -3, 5, laid out at the top with index labels 0, 1, and 2. Our running trackers sit at the bottom. Phase 1 is case 1, the standard maximum subarray sum using Kadane's algorithm. We start at index 0 with value 5. Current max is 5, and max so far is 5. We highlight the subarray containing just index 0. At index 1, we see -3. We ask, should we extend the previous streak? 5 plus -3 equals 2. Or should we start fresh at -3? 5 is better, so we keep 5 as our current max and max so far. The best middle subarray still ends at index 0. At index 2, we see 5. 2 plus 5 equals 7. 7 beats starting fresh at 5, so current max becomes 7. Max so far updates to 7. The winning middle subarray is indices 0 through 2, with sum 7. Phase 2 is case 2, the circular wraparound logic. First, compute the total sum. 5 plus -3 plus 5 equals 7. Watch the total sum tracker update to 7. Now find the minimum subarray sum using Kadane's in reverse, hunting for the smallest streak. At index 0, value 5. Current min is 5, min so far is 5. At index 1, -3. 5 plus -3 is 2, but -3 alone is even smaller. We start a new minimum streak at -3. Min so far becomes -3. We highlight index 1 as the worst middle segment. At index 2, 5. -3 plus 5 is 2. -3 remains our min so far. The minimum subarray is just index 1, sum -3. Phase 3 is the circular payoff. Circular max equals total sum minus minimum subarray sum. 7 minus -3 equals 10. Watch the circular arc connect index 2 back to index 0, skipping the -3 in the middle. That wraparound subarray is 5 plus 5, which equals 10. Comparing our two candidates, 7 from case 1 and 10 from case 2, the winner is 10. This represents the circular subarray at indices 0 and 2, skipping -3 in the middle. Now, let us look at the Python code. We initialize 4 variables, max total and current max for the maximum sum, and min total and current min for the minimum sum. We also track the total sum. We loop through the array once, updating all variables. Finally, we return the maximum of max total and total sum minus min total. There is one tiny edge case: if all numbers are negative, total sum minus min total would be 0, which represents an empty subarray. In that case, we just return the standard max total. Looking at the complexity, the time complexity is O of n, because we traverse the array exactly once to calculate all values. The space complexity? O of 1. We only used a few variables to track our sums, making this extremely efficient. And that is the Maximum Sum Circular Subarray challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.